Today's lesson, we're going to explore a little more about the rate of change from graphs and tables. So this is kind of like a review, but it should be a good one. So today we're going to talk about the Merino Community Center. So they have a pool, and it says every year the community center drains all the water from the swimming pool to perform maintenance tasks. Here's the animation that's going to show how the volume of water changes over time. So notice how the pool is clean. After 0 hours, so that's the starting amount, there's 1,200 gallons of water in there. After 2 hours, there's now 900. 4 hours, there's 600. 6 hours, there's 300. And 8 hours, the pool has been drained. Okay, so we want to know what is the rate of change. So if we go back to our notes, we can fill in that table. So we just saw this on the screen. So again, for 0, the starting amount of the pool was 1,200. After 2 hours, it was 900. 3 hours, it was 600. Oh, I'm sorry, this was 4 hours. 6 hours, it was 300, and 8 hours to have completely no water left in the pool. So to find the rate of change of water in the pool for 3 different instances, I'm going to tell you it's constant. So we just need to do our jumps and then do 1. Okay, to get from 0 to 2, you would add 2. 2 to 4, you would add 2. 4 to 6, add 2. 6 to 8, add 2. To get from 1,200 to 900, you would subtract 300. And for actually all of these, you are going to subtract 300. Since all of your numbers in your x column are constant, are the same, all your numbers in the y column are the same, then we just have to do this once to see that the rate of change would be our change in y, if you remember, over our change in x. So negative 300 over 2. If you can again simplify, please do. This would be negative 150. But what does this negative 150 mean? Okay, so it means that it's draining 150 gallons of water per hour. Okay, because it really is negative 150 over 1 per hour, 1 hour. So the rate of change tells you that it is constant. So meaning the pool is draining at a constant rate. The negative in the situation makes sense because your pool is draining. The water is going down. So yes, the pool, or I will say the water, is going down. If the water was filling up the pool, then you would need the positive. It would need to be a positive 150 because then the water would be going back into the pool. But in this case, it's going out of the pool, so we have to have negative. So the rate of change was positive. We would say the pool is filling up. I hope that makes sense. So if you turn the page, here's another example. The Booster Club is selling hats. So if they sell 0 hats, they've collected $0. If they sold 1 hat, they've collected $10. If they sold 3 hats, they collect 30, and so forth and so on. So let's find the rate of change. So if we find all our jumps, we have 0 to 1 is plus 1, 1 to 3 is plus 2, 3 to 5 is plus 2, 5 to 6 is plus 1, and 6 to 9 is plus 3. These are not constant numbers. So we're going to have to take the rate of change 3 times. 0 to 10 is plus 10, 10 to 30 is plus 20, 30 to 50 is plus 20, 50 to 60 is plus 10, 60 to 90 is plus 30. So the first one we're going to look at is when we have 1 cap sold. It's $10 for your rate of change here, and then 1, which simplifies to $10 per cap. Okay, the next one we're going to look at is when we have a 2. So our rate of change for y, or our change in y, is going to be 20 over our rate of change for x is 2, which then again simplifies to 10 over 1, which is $10 per cap. And lastly, we have to do this one here with the 3. Okay, notice how if we have these different rates of change, we don't have to repeat the 2 and the 1 because we know that they're the same over here, so they're going to simplify. So we'd have 30 over 3, which simplifies to 10 over 1, or $10 per cap. So our rate of change is $10 per cap, and it is a constant rate of change. Does this rate of change make sense in the situation? Yes, because every hat they sell is $10, and so if they sell 1 hat, 2 hats, 3 hats, 9 hats, it's $90, so it'd be 9 times that $10. If the booster club sold 12 caps, how much would they collect? So we know that the rate of change is 10, and it's $10 per cap, so that's what X represents. So if we were to say 10 times 12, they would have $120. If we think back to independent and dependent, independent is what changes the overall outcome of the dependent. So our independent variable is going to be the number of caps sold. And if you remember, we can also say it's our input or our X value. Our dependent variable is total amount collected. Talking about the money. So if however many caps they sold, that's how much they would have had to collect. So here's one more example. When pedaling on a stationary exercise bike, the number of calories you burn depends on the number of minutes pedaling. So this one isn't written in our vertical table, it's now a horizontal table, but this tells you the number of calories you burn is your dependent variable, because that always depends on your independent. So if this is your independent, this is your dependent, we just have to go like so. So our jumps would be horizontal. So 0 to 15 is plus 15, 15 to 30 plus 15, 30 to 45 plus 15, 45 to 60 plus 15, 60 to 75 plus 15. Here we have plus 105, which means that's 105 calories you burn, and that's going to be the same all the way down. So our rate of change, remember, is change in y over change in x. So we have our y value is 105, our x is 15. If we were to simplify this, it means we burn 7 calories per minute when we are working out on our bike. I wonder how many it would take to burn off that big Snickers bar I had the other day. Just kidding. It was a Reese's. Is this rate constant? Yes, and it's constant because all of our values are the same on both top and bottom. So what you're going to do now is you are going to work with a partner on the partner worksheet. Please make sure both your names are on the worksheet. You can turn in both or one with both names. It is the rest of the class time is what you have to work on it. You must turn it in before you leave. Otherwise, you have a homework assignment if you finish the group work in class, which is worksheet 4. And I'll see you tomorrow.